The new topic is polynomials, and the first lesson is just going to be explaining a little bit about what a polynomial is and then looking at how we evaluate a polynomial. Here we've got a number of expressions with various letters. All of these are examples of what we call a polynomial. We need to be familiar with one or two terms associated with polynomials, and the first one is just to be able to state the degree of the polynomial. And it's fairly straightforward, it's just the value of the highest power. So for example, in this 3 below, the first one is a polynomial of degree 4, since 4 is the highest power. The second one is a polynomial of degree 3. And the third one, if you take a moment and multiply it out, you would see that it is a polynomial of degree 2. So the first proper example we're going to look at is a function f of x equals 7x to the power of 4 minus 20x squared plus 15x plus 2. So the function itself is a polynomial, and we're trying to evaluate it for x being equal to minus 2. We'll look at a couple of methods. The first method is nothing new at all. All we're doing is substituting in the number minus 2 in place of the letter x every time. So when we do that, we get 7 times minus 2 to the power of 4, and minus 20 times minus 2 squared, etc. And it's just a case of taking your time, going through it step by step, trying to evaluate it. In some cases you might be just putting that straight into your calculator to get an answer. In some instances you'd need to be able to work it out without a calculator. So you just need to take a moment to think through that, just to make sure you're happy with all the numbers that we get there. And the final answer that we obtain when we put in a value of x equals minus 2, the value we obtain for the function is 4. Take a moment and check that through and make sure you're happy with each step. So that's simply how you evaluate a polynomial, nothing new. However, at higher maths, some of the polynomials and functions that we'll be trying to evaluate are quite a bit more complicated than this, and they can involve fractions, etc. And we've got an alternative method which I'm going to look at just now. So the alternative method is to use what's called the nested form. So this is it set up here, and it's probably started us probably halfway through this example. It possibly looks a little bit daunting to you just initially. However, we'll go through it step by step, and hopefully you'll see that it's fairly straightforward. The first thing you might notice is we've put in this 0x to the power of 3. In the original function, there wasn't an x to the power of 3 term, but when you use the nested form, it's really important that you don't miss out any terms. So when there is a term that's missing, as was the case here with x to the power of 3, you need to put it in with a 0 coefficient in front of it. So when you put it down in the table, the top line of this table becomes 7, 0, minus 20, 15, 2. And the number to the left of this line here is always the value of x that you're putting into the function, in this case minus 2. These numbers here are what we get once we've actually gone a bit the way through, and I'll just try and take you through where they came from, and then we'll finish it off. So first of all, once you've set up the top line, you just bring the 7 down to here. You then multiply that 7 by minus 2, and we'll get an answer of minus 14. I then add the 0 and the minus 14 together to get minus 14 down in the bottom line. I then multiply that minus 14 by the minus 2. That gives me an answer of 28, which I add to the minus 20 in the top line to give me an 8 down here. And I keep doing that. Next number here is going to be minus 2 times 8. So it's going to be, technical issue here, just bear with me. We're having minus 16 in there. Minus 2 times 8 is minus 16. I'm going to add them. 15 plus minus 16 is minus 1, and minus 2 times minus 1 is 2, and 2 plus 2 is 4, and that 4 is our final answer. So we can just tidy it up, finish it off by saying that the function, when we put minus 2 into it, gives us an answer of 4. And that essentially is using the nested form. I've got an example down here, just taking a closer look at it. I've tried to explain where things come from. So we'll just start by bringing the 7 down, and this is minus 14 came from doing minus 2 times 7. Then we added 0 plus minus 14, etc. We're now going to use the nested form to evaluate this function here. Well, in fact, we'll start off by looking at the usual form, just by substituting the value of minus 2/3 straight into the function to see how we get on with that. So the first line is straightforward. All we're doing is replacing the letter x with minus 2/3. And then it becomes a little bit more tricky because we need to work all this stuff out. If you're putting it into a calculator, it would probably still be quite tedious to type into a calculator. If we don't have a calculator, then, as I'm sure you can imagine, there's plenty of room for making mistakes here. Minus 2/3 cubed multiplied by 6 is going to give us minus 48 over 27. Minus 2/3 squared, well, it's going to give us, on the top line, it's going to give us a 4, on the bottom line, it's a 9. That 4 is multiplied by the 29, take account of the signs, etc., and we're going to end up with minus 116 over 9, and you keep on going through that, trying not to make a mistake, and you end up with this horrible thing here with loads of fractions to add. Obviously, if you're doing it without a calculator, you'd need to have common denominators, etc., and finishing off getting an answer of 3. An alternative approach, as we described, was to use the nested form. So to do that, you set it up as shown down here. We've got an x cubed term, an x squared term, an x term, then a constant at the end, that minus 9. So there's no missing one, so we can just set up the top line like this. We're evaluating it for minus 2/3, so it goes to the left here. And then we just set up this table and figure out what values go where. We'll start off by bringing the 6 down, that's our starting point. We multiply minus 2/3 times 6. So that's actually a fairly straightforward calculation. 1/3 of 6 is 2. Multiply it by minus 2 gives us minus 4. Add these numbers up. Minus 29 minus 4 gives us minus 33. Conveniently, that's in the 3 times table as well. So minus 33 divided by minus 1/3 gives us 11 on the bottom. So it gives us 11 multiplied by 2 gives us 22. Add these up, minus 40 plus 22 gives us minus 18. And now we're doing minus 2/3 times minus 18. Minus times a minus makes a positive. 18 divided by 3 is 6. Multiplied by 2 is 12. Add these up, minus 9 plus 12 gives us an answer of 3. So the answer for this function, when we evaluate it after putting minus 2/3 into it, gives us an answer of 3. So we've got the method that you're probably more familiar with, and we've got this new method called the nested form, which I think makes ones like this more manageable. Here are some examples for you to try, and you'll find them in your notes.